Welcome students for the today's lecture. In the video, we'll see some of the solved examples. So mainly focusing on KCL, KVL, and equivalent resistance based on series parallel combination and star data transformation. So first sum. So find the current I1 and I2 in the given circuit. So unknown I1 and I2. So So we can use Kirchhoff's current law. So first of all, we shall find I1. For that, we will take node A. So node A, we will apply KCL. So here incoming current, so I1, and outgoing current is 4 ampere and 3 ampere. So answer will be, so I1 is equal to 3 plus 4. At least that is incoming is equal to outgoing. Therefore I1 is equal to 7 ampere. And then, so we are applying KCL at node B. So here incoming current is 3 ampere and I2, outgoing is minus 2 ampere. So then the equation will be I2 plus 3 is equal to minus 2. The answer will be minus 5. So I2 plus 3 is equal to minus 2. So if you want, you can change the direction. Based on that, you can change the polarity. So minus so அதுக்கு plus 2 போட்டுட்டு arrow marker மாத்துனா it will be like I2 plus 3 plus 2 is equal to 0, then I2 is equal to 5 ampere. So answer minus 5 ampere. So answer changes irukadu. Now I1 is equal to 7 and I2 is equal to minus 5. So next sum, find the voltages V1, V2, V3 in the given circuit. So unknown V1, V2, V3. So இதுல இருந்து first ஒரு unknown இருப்போம், and then இந்த loop second unknown, and then finally இந்த loop third unknown இருப்போம். So first loop we are taking this one. So இங்க இப்போ KVL apply பண்ணோம் அப்படின்னா, so we will take the outgoing current 30. So அப்படின்னா எப்படி வரும்? Plus 20 plus 25 minus 10 minus V1 is equal to 0. So which will be equal to V1 is equal to 35. So again next one is second loop. So in the loop we can apply. Current direction is clockwise. So minus 15 plus V2 plus 10. So answer will be 5 volts. So minus V2 minus 15 plus V2 plus 10 is equal to 0. So V2 is equal to 5 volt. Next we can apply in this loop because we know the value of V1 and V2. So if you apply, the answer will be plus V1 minus V2 minus V3 is equal to 0. So plus V1 minus V2 minus V3 is equal to 0. Substitute the value of V1 and V2. The answer will be V3 is equal to 30. So these are the answers: 35, 5 and 30 volt. So in this circuit, find the voltage VAB. So the unknown voltage VAB we have to find. So for this, first we have to find the current I. So if we know the value of current I, we can find VAB. So for that, first we are taking the outer loop. So entire loop. So this is the entire loop. First we are taking outer loop and we are applying KVL. So by applying KVL, the equation will be plus 30 minus 3I plus 10 minus 5I minus 8 is equal to 0. So this will be our KVL equation. From that, if you just simplify, current will be I is equal to 4 ampere. So we have found the current value. Now we just apply the KVL to this loop, inner loop alone. So this is our inner loop. So loop 1. So we are applying to here only 33 and 10 to VAB. So here we are going to apply KVL. The equation will be plus 30 minus 3I plus 10 minus VAB is equal to 0. So we know the value of I, just substitute the value of I, and the VAB will be equal to 28 volt. So answer is VAB is equal to 28 volt. So find the current I0 in the given circuit. So here we have a dependent source. It's a voltage source. It's dependent on the current I0. So I0 is flowing to the 4 ohm. So the total current in the circuit is I0. So simply apply the KVL. If you apply the KVL, the equation will 36 minus 4 I0 minus 5 I0 is equal to 0. So simple equation. From there you can easily find the value of I0. So I0 is equal to 4 ampere. So here even though it is a dependent, this is a simple circuit. Why is because the total current is the source for the voltage source. So this voltage source was controlled by the total current. So that's a easy one. Hence this the equation become much simple and the answer is 4 ampere. And here find the voltage Vx in the given circuit. So before that we will choose the current as a I which is flowing clockwise direction like this. So we are choosing a current I which is flowing clockwise direction. So here Vx, so Vx is a voltage across 5 ohm. So Vx is equal to voltage across 5 ohm. So as per Ohm's law, V is equal to I into R. So R is equal to 5. So total current we have chosen as I. Then Vx equal to 5I. So the value of Vx is 5I. Now just apply the Kirchhoff's voltage law. Then what will the equation? 15 minus I minus 2Vx minus 5I minus 2I is equal to 0. So this is our equation. So here just substitute the value of Vx as 5I, and the equation will become like this. So just separate or solve the equation. So answer will be 15 minus 18 is equal to 0. From there I is equal to 15 by 18. So total current will be I is equal to 0.833 ampere. So we already know what is Vx. Vx is equal to 5I. So just substitute Vx equal to 5I, I is equal to 0.833. The answer will be nearby 4.165 volts. So this is the value of Vx. So here, so find the total current in the given circuit. So here we have a voltage source which is supplying 3 lamps, each of one 30 watts, another one 40 and another one 50. So from this we can find the total power supplied by the voltage source. So total power supplied is 30 plus 40 plus 50. So total power is 120 watt was supplied. So we know power is equal to voltage into current. So we know the voltage and we know the value of power. From this we can find the value of current I. So I is equal to P by V. So 120 by 100. The answer will be 1.2 ampere. So this is your answer. So here find the total current supplied by the voltage source in the given circuit. So what is the total current supplied by the 12 volt source? So for that we need to find the R equivalent. So we have V. If you know the value of R, we can find the current I is equal to V by R. So for this, so first of all 10 ohm, 20 ohm and then this is 10 ohm. These are in series. So answer will be 10 plus 20 plus 10 which will be equal to 40. So then diagram becomes like this. So these three branches cannot be a single branch. So here 40 ohm and 40 ohm both are in parallel. So 40 by 2. So answer will be 20 for this. So circuit will become like this one. So these two branches are replaced by 20 ohm. So here again 8 ohm, 20 ohm and 12 ohm. Three resistors are in series. So which will be equal to 40. So 8 plus 12 plus 20 which is equal to 40. So we can replace the 3 resistor by single resistor. Again 40 ohm in parallel. So which will be equal to 20 ohm. So then the circuit will become like this. Here 20 ohm and 20 ohm both are in series. So the equivalent resistance will be 40 ohm. So this is our equivalent resistance. So we have found the R equivalent. So we know the value of voltage also. So by Ohm's law V is equal to IR. So we need the value of I. I is equal to V by R, which will be equal to 12 by 40. The answer will be 0.3 ampere. So this is the answer. So find the equivalent resistance RAB in the given circuit. So this is the given circuit. Our aim is to find the equivalent resistance across these 2 points. So here see 30, 10, 40. This is in star connection, or else 10, 40, 50. This is in delta connection, or 30, 10, 60 in delta connection. There is nothing, no resistor in series or parallel combination. Everything in star or delta format in this element. So our plan is to just take any one connection like delta or star and convert to another transformation. If I am taking 40 ohm, 10 ohm, 50 ohm as a delta connection, I can change this to a star connection like this. So we can change this delta connection formed by 10 ohm, 50 ohm, 40 ohm to a star connection like this. So if we connect it like this, so then the 30 ohm and this resistor will become series, and 60 and this resistor will become series, and both are parallel. After that these three will become series, like that the circuit will change. So first of all, our aim is to convert this delta to a star. So delta to star, the formula is, so in the numerator product of adjacent resistor, the denominator sum of all the resistor. So R1 is equal to 10 into 40 divided by whole resistor, 10 plus 40 plus 50. So answer will be 400 by 100, 4 ohm. Similarly for R2, it is 10 into 50 R2. For R3, 40 into 50. So these are the values of resistance. Now the circuit becomes like this. So the delta connection was converted to a star connection. So now we can say 30 and 40 is in series. Similarly 60 and 5 ohm in series. So and then 20 and 80 also in series. So we are just converting these 6 resistor to a 3 resistor. So like this. So 20. So here both are in parallel and 100 ohm. So 34 and 65 are in parallel. So for that the equivalent resistance will be 22.22. Just replace this resistance. So 20, 22.2 and 100. So three resistors are in series. So R equivalent will be sum of the three resistors. So 20 plus 22.2 plus 100. So answer will be 142.2 ohm. So RAB is equal to 142 ohm. So the final problem, find the equivalent resistance RAB in the given circuit. So in the circuit you can simply say 20 ohm, 30 ohm both are in parallel. Similarly 10 ohm and 40 ohm are in parallel, and then 5 ohm and 50 ohm are series. So just apply the same. First I'm applying 20 ohm and 30 ohm are parallel. So we can replace these two resistors by a single resistor of value 12 ohm, and then 10 and 40 are in parallel, so which can be replaced by 8 ohm, and then 50 and 5 are in series, which can be replaced by a single resistor of 55 ohm. Now the circuit will become like this. So 8 for 10 and 40, 12 for 20 and 30, and 55 for 5 and 50. So here 8 and 12 ohm both are in parallel, so answer will be 4.8. So here 4.8 and 55 both are in series. So final answer will be 59.8, which is equal to 60. So the final answer is RAB is equal to 60 ohm. The equivalent resistance is 60 ohm. So thanks guys for listening the lecture. So these are the references we have made. Thank you guys.